Okay, so I'm going to introduce you guys to someone who's pretty cool. His last name was L'Hôpital, and he's French. So, French people are pretty cool, and this guy is even cooler because he's a mathematician. Well, L'Hôpital actually found a way to solve for the limit even when we ended up with an indeterminate form. So we're going to start off with this example where we have the limit as x approaches c for f of x and for g of x, and they both happen to equal 0. So keep in mind that our goal is to figure out how to find the limit as the limit approaches x, as the limit x approaches c of f of x divided by g of x equals 0 over 0 in indeterminate form. Hopefully you can compare these two. It's pretty much this one divided by this one, and since they're both equal to 0, we have our indeterminate form. Okay, so the first step is to find the tangent line. Hopefully you guys also agree that if the point itself approaches 0 as x approaches c, then the tangent line will also approach 0. So we have the tangent of f of x, which equals, if you guys recall your slope-intercept form, we have the slope, which would be the derivative of the function f of x at point c, multiplied by x minus c, which is the x point, plus whatever our y value is at that point c, which in this case would be f of c. And similarly, our tangent line for g of x would equal the same thing, except for we're replacing all the f's with g's. Alright, so if we were to replace this with our two tangent lines, we would get something like this. Our tangent f of x divided by tangent of g of x equals our limit as x approaches c of the derivative at f of c multiplied by x minus c plus f over g derivative of g of c multiplied by x minus c plus g of c. Okay, so you guys recall that when we're trying to find the limit as x approaches c, we pretty much the first thing is to put the c right here, which gives us a 0. And if we do that for g of x, we know that this equals to 0, and this also equals to 0. So now we're left with this part to solve. Well, we know that this divided by this is equal to 1, so we can cancel these two out, and we are left with the limit as x approaches c of the derivative of f of x at point c divided by the derivative of g of x at point c. So if you take a look at these two, they're supposed to be equal to each other. In other words, the limit as x approaches c of f of x divided by g of x is actually equal to the limit as x approaches c of the ratio of their derivatives, or their tangent lines. So I think that's pretty cool, and remember, this L'Hôpital dude figured this out.